Inverse functions, sections 1.7 and 3.8. If reversing inputs and outputs of a function results in a function, the new function is called the inverse of the original function. Function which has an inverse function is called invertible or one-to-one. The following example will illustrate the difference between inverse function and some other types of inverses. In this example, c is equal to 5/9, parentheses f minus 32. And this is a formula for converting Fahrenheit temperatures into Celsius temperatures. Because there's only one formula for C, Celsius is a function of Fahrenheit. If you solve this equation for F, that results in the formula F equal 9/5 C plus 32. And because there's only one formula for F, Fahrenheit is also a function of Celsius. Because the new formula is the inverse of the original formula, in the sense that it reverses the new formula is the inverse of the original formula because it reverses the process of converting temperature from Fahrenheit to Celsius, as illustrated in this table here. If you're converting from Fahrenheit to Celsius, you first subtract 32. So you look at the formula inside parentheses, we have f minus 32. You first do what's inside parentheses. So that's the first thing we do is subtract 32. And the formula for converting from Celsius to Fahrenheit, the last thing we do is add 32. So it's a different order. We're doing the opposite operation. We're adding instead of subtracting, and we're doing it last instead of first. So if you look at the formula for Celsius to Fahrenheit, multiplication comes before addition. So we do the multiplication first and then the addition. For Celsius to Fahrenheit, or Fahrenheit to Celsius, after we subtract 32, we multiply by 5/9. So we do what's inside parentheses first, and then we do what's outside, multiplying by 5/9. For Celsius to Fahrenheit, that's the first thing we do. Multiplication comes before addition, and we multiply by the reciprocal of 5/9, which is 9/5. So we multiply by 9/5. So we have several types of inverses here. We have 32 is the additive inverse of negative 32, and 9/5 is the multiplicative inverse, or it's also called the reciprocal of 5/9. And also we have a different order. We reverse the order of operations here. Okay, so 32 is additive inverse of negative 32. 9/5 is the multiplicative inverse of 5/9. And the new formula also reverses the order of operations of the original formula. And the result is an inverse function that reverses the process of converting Fahrenheit to Celsius. So the inverse function sort of combines several types of inverses here. And but generally, inverse functions, they don't necessarily involve additive inverse or multiplicative inverses. This one happened to involve several different types of inverses, so I use this as an example to sort of illustrate the differences. But not all inverse functions involve inverting addition or inverting multiplication. They may involve, for example, square rooting in some cases can be the inverse of squaring, and there's no additive inverse or multiplicative inverse involved in that process. Okay, so another example, find the inverse function of a discrete function here. This is a set of 3 points, 1, 4, 2, 5, 3, 6, and its domain. So here, generally, when you're inverting functions, you're switching the roles of x and y, or f and c, or whatever letters you're working with. In this case, we want to switch the first coordinates and the second coordinates. So instead of 1, 4 for the inverse, we'll write 4, 1. For 2, 5, we'll write 5, 2. For 3, 6, we'll write 6, 3. So the domain of the inverse is now going to be the new first coordinates, 4, 5, and 6. And this is the inverse function here. The inverse function of f of x equal x squared and its domain. The steps are you want to replace f of x with y to get y equal x squared, and then switch x and y and solve for y. That's sort of a general procedure for getting the inverse. And if we solve this for y, we get x equal y squared, and take the square root, we get y equal plus or minus the square root of x. And because there's two formulas for y, the inverse is not a function. We can get an inverse function if we restrict the domain here of the original function. If we restrict the domain to either positive values of x or negative values of x, then we can get an inverse for that function with the restricted domain. But if we're using the entire domain of the original function, then there's no inverse. Inverse function of f of x equal 1 over x minus 3 and its domain. Again, this is sort of a general procedure for getting an inverse. Instead of writing f of x equal, we'll write y equals, and then we want to switch x and y and solve for y. So we have y equal 1 over x minus 3. Switching x and y, we get x equal 1 over y minus 3. And we want to isolate the y. First of all, we want to get y out of the denominator. So we multiply both sides by the denominator, y minus 3. On the right side, the y minus 3's will cancel, and we'll have 1. On the left side, we want to distribute the x, so we'll have xy minus 3x equals 1. And then we're still working on isolating the y. We can add 3x to both sides to get xy equal 3x plus 1, and then divide by x to get y equals 3x plus 1 all over x. So the third step, instead of writing y equal, we'll write f inverse of x equals. So f inverse of x equals 3x plus 1 over x. And the domain here would be, this formula works as long as x is not equal to 0. You can't have 0 in the denominator. This notation here is the same notation that is used for multiplicative inverses, but this in this context, this minus f to the minus 1 power, it looks like f to the minus 1 power, but in this context, it means the function inverse rather than the multiplicative inverse. Okay, so one of the properties of inverse functions is that if you compose a function with its inverse, you should get back just the identity function x. So if we do I'll show f composed with f inverse is equal to x, but you can also show that f inverse composed with f is equal to x. Okay, so f composed with f inverse, we want to, in the formula for f of x, we want to write f inverse of x instead of x. So instead of 1 over x minus 3, we'll have 1 over f inverse of x minus 3. And then write the formula for f inverse, which we just computed to be 3x plus 1 over x. Substitute that in. And then we want to simplify this. We have a fraction within a fraction. To get rid of the fraction within a fraction, we can multiply each term by the denominator, which is x. 1 times x is x, and 3 times x is 3x. And this term here, the x's will cancel. The bottom left, the x's will cancel, we'll have 3x plus 1. Then 3x minus 3x is 0, so we just have x divided by 1, which is x. So that confirms that, at least partially confirms that f inverse is indeed the inverse of the original function f. And likewise, you can also show that f inverse composed with f of x is equal to x. You can also get the graph of an inverse function from its graph. And if we want to graph the inverse of this function here, it looks like a parabola. The answer is that the function fails the horizontal line test. The inverse is not a function. So that's as far as we need to go. It's a function because it passes the vertical line test. Wherever you draw a vertical line, it only crosses in one spot. But there's a lot of places where if you draw a horizontal line, it'll touch in more than one spot. So this one's not, the inverse is not a function. Here's another example. Graph the inverse of this function here, and this one does have an inverse. It's a function because it passes the horizontal line test, the vertical line test rather. Wherever you draw a vertical line, it only touches in one spot. It's also its inverse is also a function because wherever you draw a horizontal line, it also touches in one spot. And the way we get the inverse is reflected across the line where y is equal to x. So this dotted line here is where y is equal to x. Remember, for the inverse, we're basically switching the roles of x and y. So if it's the inverse is just going to be the mirror image of this function if we flip it across this dotted line here. And I drew the inverse in a darker color so it could, to distinguish it from the original function here. So this would be f inverse here. And that concludes this presentation.